Welcome to BobMath. In this video we have a new exercise for geometry. Well, our exercise is as follows. We consider the figure as this side such that we have a right angle triangle BCD, and we have a straight line CF perpendicular to straight line BD. So the questions is as follow. Show that BC plus CD less than FC plus BD. Always before discussing the solution, try to complete the exercise to increase your skill in mathematics. Then complete the video. Now we have area of triangle BCD equals BC times CD divided by 2, and the another two way FC times BD divided by 2. Now we multiply the equal by the n number 4, so we got 4 times BC times CD divided by 2 equals 4 times FC times BD divided by 2. Now we simplify the n number 2, so we got 2 BC times CD equals 2 FC times BD. We call this inequality alpha. And now we have FC plus BD all squared equals FC squared plus BD squared plus 2 FC times BD. Therefore, FC plus BD all squared equals FC squared plus BD squared. Now from alpha we conclude that plus 2 BC times CD. We call this inequality 1. And we have BC plus CD all square equals BC square plus CD square plus 2CD times BC. And we call this inequality 2. Now we subtract the equal side by side. So we got BC plus CD all square minus FC plus BD all square equals BC square plus CD square plus 2CD times BC minus FC square minus BD square minus 2CD times BC. Since the triangle is a right triangle, then according to the Pythagoras theorem, so BD square equals BC square plus CD square. So BD square minus FC square minus BD square. Therefore BC plus CD all square minus FC plus BD all square equals minus FC square. So this number is negative. Therefore BC plus CD all square minus FC plus BD all square less than 0. Therefore, BC plus CD all square less than FC plus BD all square. Since this expression is positive, then BC plus CD less than FC plus BD. Therefore, this is the relationship required in this exercise. Thank you for watching, and please don't forget to subscribe to my channel for more exciting videos.